Today we will be discussing about rolling of metals. It is like module 6, lecture number 1. And when you come to this rolling, metal rolling, this rolling is a very extensively and widely used metal forming process, especially in metal industries. And this is the process of plastically deforming metal by passing it between two rolls. Okay. So, if you look at any industry where they manufacture these strips or sheets or plates or even foils, these are most of them are manufactured by a rolling process in a continuous way, or sometimes in a batch wise also it is manufactured. So, almost all types of sections are made by rolling. So, you talk about a square section, cylindrical section, the channel section, the I section, the X section, and even say non-ferrous metals, the door frames, they have a very complicated sections also. So, that also to some extent can be, not all, to some extent it can be made. But in general, for structural application where you want certain sections, standard sections, then rolling is the solution for that. So, that is why you will find the rolling as a very big industry in metal industries. So, this rolling has the advantages of other metal deformation processing, like say it has very high production rate on a continuous basis, continuous rolling mill, continuously it will give. If you want very thin sheets from a billet or a bloom, then you continuously get it, and it is coiled into say in a coiler and then get it in a roll form. If you want to say certain specific lengths also of different sections, that also you can have it. So, it provides very high production rate, and it also gives very close control of the final product. So, dimensional tolerances are very good. The mechanical properties are being enhanced because of the rolling, depending upon say if it is cold rolling, the mechanical properties get increased due to work hardening behavior during the deformation. So, and you get more or less uniform thickness for each section. So, that is the biggest advantage in metal rolling, and on a continuous basis, on a continuous way you are going to get it in a continuous process. So, when this metal, the initial material is introduced into the metal, into this the gap between the two rolls, the metal is being squeezed by the two rolls, the pair of rolls. So, these are counter rotating rolls actually. And when it is squeezed, it results in compressive stresses at the inside the material. So, the chance of having metal defect is very less, because under compression it is very difficult to have defect formed, like voids and other things formed. But under tensile stresses definitely the voids can form, but under compression we can say that a general theory, a belief is that you cannot fail any material under compression, but it is not 100%. Isostatic compression is not there, but still the compressive stresses are developed. And then when the material passes between the rolls, there are because there is a relative motion between the workpiece and the rolls. So, you will find that at the interface, the roll and the workpiece interface, there are frictional forces are being developed, and when these frictional forces are developed, this results in surface shear stresses. Okay. So, the frictional forces are responsible for drawing the metal into the rolls. If there is no friction, it is very difficult to do the rolling operation, because otherwise you may have to give external force, so that the billet is just forced into that in between the rolls. So, but if there are friction, then automatically it can be rolled above the friction. The coefficient of friction should be more than certain limiting value, then the roll itself will draw the metal inside into the roll gap itself. So, those are the main advantages of metal rolling process. We can classify this rolling process into say hot rolling and cold rolling. The hot rolling is basically referred to as the initial breakdown of ingots into blooms and billets, and is generally done by the hot rolling process. Because if you look at especially steel industries, non-ferrous may not be that much, but steel industries, if you look at it, you get the metal in the cast form, in an ingot form you get it, and these diameters are very large. It may be somewhere around even 1 meter also, or even more, and with a height of almost L by D ratio is more than 1.5 also. So, you may get that cast very big billets, or sorry, ingots are obtained, and this, because its size is so large, it will contain all sorts of microstructure. Maybe at the surface you may find an equiaxed, a very thin layer of equiaxed structure at the surface you will find, because of the rapid cooling when the molten metal comes into contact with the metallic die when you are making a big ingots. Then you will find there are columnar grains are there, and after some time towards the center when you move, the columnar grains may end up into say columnar dendritic structure, and finally dendritic structure you will find. At the center, depending upon the alloy, you may also find the equiaxed dendritic structure also. All these sorts of, so from the surface to the center, you will find the microstructure is changing. The microstructure of the material is changing at the level of an optical microscope, if you look at it. I am not talking about say under transmission electron microscope. And at the same time, because of these conditions of cooling and depending upon the thermophysical properties of the metal, you may find a large amount of segregation and coring also. So, the microstructure from the center to from the surface of the ingot to the center of the structure, if you look ingot, if you look at it, it is a very complicated structure. It is not a homogeneous structure. So, this has to be broken down. So, for that purpose, with a very high diameter and other things, if you wanted to do cold rolling, you may need, the power requirement will be very high because of the work hardening. So, what you do is that you go for hot rolling. So, that initial breakdown of the ingot into blooms and billets, this is done by the hot rolling operation. Even hot rolling operation, subsequent operation also will be done by hot rolling, but it is not necessary. So, further hot rolling also is carried out to obtain products in the form of plates, sheets, rods, bars and other things. That also is done. The advantage is that when you are going for a hot rolling operation, your power requirement will be very less. That is the biggest advantage, because a rolling mill itself consumes large amount of electricity. So, when you are doing the hot rolling operation, the power requirement for the rolls, that is can be reduced considerably. So, generally people prefer the hot rolling to obtain say even plates or sheets or rods and bars, but maybe the final structure before use people may go for cold rolling. So, cold rolling, the advantage is that this difference is that in the temperature. The temperature is hot rolling is that process which is carried about above the recrystallization temperature of the alloy, and if that is done below the recrystallization temperature, then you refer to as cold rolling, and it is carried out by industries to obtain thin sheets, strips, foils. Okay, this is foils. Okay, not files, and bars, etc. The advantages are they have very good surface finish. When you are doing in the cold condition, good surface finish is obtained. Whereas when you are doing the hot rolling, the metal many times the surface may get oxidized at a higher temperature, and this is too much with the non-ferrous materials. Steel also gets oxidized. So, oxide layer comes into picture. Sometimes if you do not remove it, then okay, built up scales will form into that, and then it ends up in defects. But whereas these problems are eliminated in cold rolling, because at room temperature the extent of getting oxidized is very less. So, and then you have a better dimensional control. So, you get a very good surface finish. The close control of the dimensions of the product can be obtained because of this, because other operations can be eliminated because you are getting the very good surface finish with the very precise dimensions also you are getting. Whereas in hot rolling, the temperature may vary. When the temperature varies, your dimensions also may vary. So, because that is of practical difficulties are there. And in cold rolling, because the metal is being plastically deformed in the cold condition, the metal is not softened. Okay. So, the temperature dependent phenomena, metallurgical phenomena are eliminated, say like dynamic recrystallization, dynamic recovery, these things are eliminated, and the metal gets work hardened. So, there is an increase in the mechanical properties like strength and hardness, but at the same time there will be a decrease in the ductility. When the strength is increased by plastic deformation or hardness is increased by plastic deformation, then the toughness of the material gets decreased, the ductility of the material gets decreased, the malleability of the material gets decreased, the brittleness increase, all these things happens. But to some extent, as per the requirement of the use, you can have the material with a specified mechanical properties like strength and hardness and ductility, which is acceptable by the industries. Before we go further, I was talking about this billet, bloom, slabs and other things. So, one should know what are the these terminologies, okay, what it refers to. So, for example, when you talk about blooms, bloom is the product of the first breakdown of the ingot, okay, and generally it is done by, not generally, almost it is done by hot working. All of them are obtained by hot working. So, in this the blooms has the specialty, their cross sectional area is very large. You anywhere between say 150 centimeter by 150 centimeter, if a square section is there, so you will have a cross sectional area of 150 by 150 cross sectional area, and your length will increase. So, these are referred to as blooms, and these are obtained by the hot deformation, hot working process in the initial. It can be by forging, it can be by rolling, but normally people may go for forging also and get the blooms and other things, okay. Because for a rolling mill, the size will be, the weight will be very large. So, but generally people, if there is a facility for forging, then you get it by blooms. The next term is the billet. The billet is the product obtained from further reduction of the blooms, okay. So, there by subsequent reduction, by maybe by cross sectional area gets reduced from 150 centimeter by 150 centimeter, you end up with a 40 by 40 millimeter square area when you are getting it, then that is called as the billet. So, its cross section area is again the square cross section area. Now, slab is any hot rolled ingot with a cross sectional area almost 100 millimeter square and with a width greater than twice the thickness. So, that is called slab. You will find that the width is higher than the thickness. Okay. So, this is the width which you will find it is higher than the thickness. And then you have the plate. Plate is the product with a thickness generally referred to a thickness which is greater than 6 mm. But though there are certain cases, the exceptions are there, but depending upon the thickness and the width. But normally it is referred to the products which having a thickness greater than 6 mm. And next is the sheet, where the thickness is less than 6 mm is called as sheet, and width will be normally greater than 600. Sometimes it may be 800, sometimes it may be 600, depending upon the roll length. Okay. So, these so that is referred to by the sheets are generally, sheets and plates are made by rolling, not by any other methods. Okay. So, here the as long as the thickness is less than 6 mm, you call it as either sheet or strip. Okay. So, if the width, the only difference is in the width. If the width is greater than 600 mm, then you call it as sheet. If the strip is, if the width is less than 600 mm, it is called as the strip. That is the difference between this. And if you look at these blooms, billets and slabs, they are known as semi-finished product, because these blooms, billets and slab may be further subjected to plastic deformation to get some specific shape, and not only shape, size, as well as specific properties, okay, mechanical properties. But whereas sheet and other things, like before the final operation, like once the operation is done by rolling, then it is not given any semi-finished product, only final. So, if it is sheet metal working, only those type things are there, but the thickness is going to remain constant. So, further subsequent processing to reduce the size or dimensions will not be there. So, that is the only thing. So, These blooms, billets and slab may be further reduced in cross section. Okay, reduction may be given to obtain plates, sheets, strips and various sections. There is another, when you call about rolling, there is also something called as powder rolling. In this, the metal powder, maybe metal means even it can be pure metal or it can be alloy powder. They are introduced between the roll and then okay, it is compacted. When it passes through between the roll, it gets compressed. So, here it gets compacted into strips, you call it as green compact or green strips we call it. Green means it has just not very high strength is there, just is able to hold it by mechanical interlocking between this individual powder particles. By cold welding they are just getting in this, but it is having some strength, it is not there. And then once it comes out, you will find it is having a very good strength, so that but not for structural application. To obtain the structural application, these are subjected to sintering, means heating it at a higher temperature. Normally, if it is on a continuous process, from the rolling mill, it will pass through a continuous heater. Okay. And after certain distance, it gets sintered, whereby the chemical bonding between the individual grains are obtained, by which is assisted by diffusion of elements from one grain to the other, and then you get a very strong material. And then it is again subjected to either cold or hot working. Because once you get sufficient strength by sintering process, it may be subjected to hot or cold working for further reduction. And during this reduction process, you will find that okay, lot of residual stresses and other things are developed. So, to remove that, the final the product will be finally given an annealing heat treatment. Okay, so that is all. So, directly from the metal powder you are getting it. Now, the advantages of this powder rolling are, you can have a very high density sheet, because there will not be any porosity in ingots, whereas in ingots there may be shrinkage porosity, there may be gas porosities like blowholes or pinholes and other things, all those things may be there. There may be metallic inclusions which has formed during the casting process. So, these things are, there is always a possibility of these type of defects in cast ingot, whereas in metallic powder, the chance is very less. You have very fine sized metal powders with a homogeneous chemical composition, or chemical homogeneity will be there, because the powder size is very small, at the level of around maybe 20-30 micrometer or even 50 micrometer, not beyond that. So, and these are the powders which are being compacted by powder rolling. So, you get a very high density of the sheet, elimination of initial hot ingot breakdown process, elimination of defects which has been formed during the initial hot ingot breakdown process. So, in the ingot, as I said, the segregation, interdendritic segregation and coring, all these things, and dendritic structure, columnar structure, everything has to be broken down to obtain more or less a equiaxial structure. But here that type of breakdown of the structure is not required, because you are almost having a very good fine structure with the homogeneous composition, chemical homogeneity is also there. And then for a rolling mill, as I mentioned, at every stage, it is not in one stage process, it is different stages are there. There are different strands are there, we will come to that soon. And for each case, the initial capital investment is very huge, because when you are having several stages of rolling process, initial capital investment will be very high. That is one part. The power requirements will be very high for it, because you may have different stages, all those things are there. So, minimum contaminants are there in the powder rolling, because your powder, you are getting a homogeneous composition for the powder metal powder. So, there is no chance of getting any other contaminants. Okay, of course, it depends upon certain material also. If it is, you are having something like magnesium and titanium, you have to take extra precautions so that it does not get oxidized. These type things are, but in general, when you say that contamination is very less. So, otherwise, when during hot working, there is every chance at a higher temperature, normal metals also will get oxidized. And like in steel, what happens is that the oxide layer which you call it a scale, that also will come and it may just get embedded inside the material during the rolling process, so that you end up with a defect. So, these type things are eliminated or are not there during the powder rolling. And then very fine grains the material with the drastic reduction of preferred orientation, because in metallic material continuously you do say rolling operation along certain particular direction. At the end you may find there is a preferred orientation, that means grains, the specific crystallographic crystal planes will get aligned along some particular direction, that is called as the preferred orientation. That will result in directional properties for the metal. But whereas in this case that the extent of forming the preferred orientation is very less. Okay. So, that these are the advantages of powder rolling. Anyway, we are not going for this powder rolling, but I was just discussing about the advantages of. Now, the rolling process is generally done in rolling mills. So, the rolling mill consists of minimum one pair of rolls or more, it can be more also, but minimum 2 rolls should be there which are counter rotating. There should be bearings, very good quality bearings, so that the rolls can be fixed inside the bearings with the help of the bearings with a less dimensional variation. Okay. And there should be a structure or a housing for supporting these parts in a very rigid way. So, because the amount of forces and the torque which are required for the rolling process is very high. So, the structure should be able to hold it rigidly. So, you should have a very rigid structure or a housing for supporting all these parts. Then there should be power drive in electricity. So, you need that power source is there, high amount of power is required, and there will be your power drive, like in the mainly the high capacity motor. High powered motors are required, very high powered motors are required. Then from the motor to the rolls there should be a proper power transmission system. So, this should be there. There should be speed control, so that depending upon the material you should be able to adjust the speed of the rolls. Not only depending upon the material, also depending upon the reduction which is required, also you should be able to adjust the speed of the rolls. And in addition to this, you should have the facility for roll gap adjustment. Very often you may have to keep on changing it. So, roll gap adjustment setup also is required. So, rolling mill consists of all these things. So, it is not a very simple case as you feel. The forces required for the rolling are very high. The power requirement is also very high. So, initial capital investment is high. So, generally the rolling mills are classified with respect to the number of the rolls and the arrangement of the rolls. So, let us come to the type of rolling mills. When you say the most simplest material is the 2-high pullover mill, rolling mill. 2-high pullover mill is what you are getting here. Okay. So, in this 2 counter rotating rolls are there with a proper roll gap between them. Okay. And then what happened, the strip enters from one end, and then you will find that with an initial thickness, the initial thickness is here, the final thickness is something around here. So, as it enters, the metal is compressed, and at the same time because of the friction at the interface surface, shear forces are developed, the metal gets elongated, its grain size gets increased, all those things happens. But finally, when it exits the roll gap, the part which is there in contact with the roll is called as the roll gap. When it exits the roll gap, you have a reduced thickness. So, the stock, once you roll it, if a mill is there with the 2-high pullover mill, what happens? You first do a rolling operation, and then once it comes out, it is again taken back, and then again adjust the roll gap, and again maybe reduce the roll gap, and again just to pass through that. So, this is generally a type of manual type of done. At a small level industries, they go for these high pullover mills. The next is that, because this is very difficult, because one operator has to stand at one end and another operator at the other end. Sometimes, depending upon the weight of this, you may need to have more than one operator at each end, and then somebody has to bring it back also. Okay. Some device for material handling should be there. So, if it is done in the hot condition, it will get cooled. All those difficulties are there. So, to overcome that, the 3 high mill is being there. So, in this 3 high mill, you have only 3 rolls. So, if you look at this part which is here, these are counter rotating, and if you look at these two, this is also counter rotating, but in the opposite direction. So, here the initial stage is you allow the metal to pass through this here in the one stage, and an operator is here. Once it goes into the through the conveyor, when it comes, he just picks it up and put it into here there. So, the material goes like this. Okay. So, that is the advantage of this pullover. So, you need only one operator here, one operator here. Once it moves into this area, that edge, the final edge is just made and put it into here. So, as per the requirement, the roll gaps are always adjusted, fixed. So, you have a particular reduction in this process which is possible. So, and these rotates were, so these are all rotating at the same speed, but depending upon the roll gap, your reduction will vary. So, simultaneously you can do this also, that is another advantage. So, it need not be sheet, it can be even rods also you can reduce by this. So, that is the biggest advantage with this. Next is the 2 high reversing mill. Okay. So, in this, the workpiece can be passed back and forth through the rolls by reversing their direction of rotation. So, at one instant these 2 rolls will be rotating in one direction, maybe let us say for this particular configuration which is shown, it will be moving, velocity will be in this direction. And once the metal passes through the other end, then your roll gap adjustment is done, and then maybe the roll gap is reduced, and then from that end, see, the rotation of the rolls are reversed in this case, second step, and then it can come into the it can move into this direction. So, this is the 2 high reversing mill which is there. Now, another case is the 4 high mill. In the 4 high mill, you will find that later when we come to the analysis of this rolling operation or mechanics of this rolling, you will find that the power requirement for rolling operation can be reduced considerably if you are using a lower diameter roll. So, that advantage. But when you are using a lower diameter roll, because the roll length is very large, there is every chance that roll deflection may take place. Okay. So, for that purpose, what you do is that this is your actual working rolls, and then this is supported at the back side by a backing roll. So, this will be the backing rolls, these 2 are the backing rolls. So, you have this working roll and backing roll. So, the backing roll will give sufficient rigidity, because the working roll diameter is very less, but by that you can reduce the power requirement. But as I said, the roll deflection will take place when the diameter is very less, especially the slenderness ratio of the roll is very high. So, you may find the uniformity in the thickness across the width may not be there. So, to avoid that only you are going to give the backing rolls. So, larger diameter backing rolls are there as a support roll. So, in that case your power consumption is reduced considerably, and the roll it will give more or less uniform dimensional dimensions, and third, with a very fine diameter with a smaller diameter roll, your surface finish can be very good. So, in this case for cold rolling, this is generally preferred, because cold rolling is done towards the final stages, and then you can get a good surface finish, as well as at the same time the reductions are possible with the thin sections and other things, and for which the power requirement will be very less. So, that is why these 4 high mills are there. Still you can have very higher cluster mills are also there. So, in that case, so you have a large number of rolls. So, each roll is supported by 2 backing rolls. So, when you look at it, this working roll is supported by 2 backing roll here, whose diameter is larger, because if it is, if in the previous case, no, only one roll support is there. So, it may shift this side the other way. So, whereas in this particular case, between these two backing rolls, no, that gap is there. So, that is held here. But then here diameter is very less. When you wanted two rolls, you cannot have a very large two rolls and then this small one. That is not possible because it may touch the billet. So, that you do not want. So, for that purpose, the first backing roll is having a diameter which is higher than the working roll, and then you have a very large backing roll, say 1, 2, 3 backing rolls, you can support these two backing rolls. The intermediate backing rolls can be supported by this very large backing roll. So, here rigidity will be well maintained, and for that purpose. So, and then this is generally done for very high speed rolling process. When it is high speed rolling process, the rigidity should be very high, your surface finish should be very high. More or less these are the towards the end of the rolling process, no, you have one stage, second stage, third stage, fourth stage, and when it comes to the final stage, the speed of the billet or the workpiece which comes out of the roll will be very, very high. Okay. So, for that purpose this is done. So, you get a good surface finish, and normally at the towards the end, the final finishing operation, the deformation, the reduction will be very less. This is one case of cluster rolls called a Sensimizer mill, which is taken, this photo is taken from the internet only. So, you can see that these are the two working rolls which are there. This is supported by two backing rolls. These two backing rolls are supported by three backing rolls with a slightly bigger diameter, and finally, you have a larger diameter backing roll. So, this is the case, this rack and pinion arrangement is the case for roll gap adjustment. When it is rotated, the whole thing, the whole system will move upward. Here also you can adjust it. So, your roll gap can be reduced by this this adjustment. So, you have all those things, and here you will see that for each roll, no, there are bearings, and what you are seeing is bearings, okay, not the actual rolling. So, no, because this is a side view which is shown there. So, it is a very complicated thing setup. So, in the rolling mill, all these things will be there at one strand itself. So, this is another large number of mills are there. So, here now this lower rack, upper rack, you can adjust these two into that. So, this can be brought down, this can be brought up, so that your roll gap can be adjusted in this case. Okay. So, you will see that secondary intermediate rolls are there, first intermediate rolls are there, second or idle rolls are there, driving rolls are there, screw down roll. So, all those from a very simple rolling mill setup to a very complicated rolling mill setup is there, but for large scale production these cluster mills are generally used. Now, if you look at the typical arrangement of rolling in a rolling mill, so a rolling mill, if you look at in certain cases when you wanted to have thin sheets, suppose you take the case for sheet metal industry where you wanted the thickness of say 2 mm, 3 mm or 1 mm, like that sheets if you wanted, or even foils if you wanted, then you will find that the number of stations are very less. So, here the initial material may be there from a uncoiler region you are having, and then from there it is just to put it into say what you call it as the first strand or the first stage of rolling. So, when it enters into that, you will find that the velocity of the metal which comes out will be higher than what was the initial before it entered, because there is a reduction. So, when the height is getting reduced, the correspondingly the length gets increased for maintaining the constant volume of the material, and then it will come to it will be the exit of the first station will be the inlet to the second strand. Okay. And there is a spelling mistake here, instead of stand it should be strand, and the exit of the second strand should be the inlet to the third strand, and so on it goes. There may be large number of rolling stations actually, or strands will be there in this case, and finally you get the very thin maybe foil or very thin sheet and other things, and if it is a continuous process it will be just winding up on a reel, and then finally you will get it. This this sheet metal which is wound around a reel, you can very often see when you stand on the roadside itself in trucks carrying this thing like a big bobbin. Only one will be there in a truck because the quantity is very large. So, you can see that is obtained by this wind up reel and other things, and you are getting it wind up because it is in a continuous form. So, the whole process, sometimes there may be more than 10, 12 rolling stations will be there. So, in that case what happened, after each stage the total rolling mill, if you look, it may length may come to something around maybe 500 meter or more. 500 meter is around half a kilometer or even more also it will come, because it is not only the rolling. To adjust this velocity between the exit of one strand and the inlet of the other strand, sometimes you may have to have pits, so that otherwise the velocity, if there is a small variation in that, then you will have problem. Okay. At one stage maybe back stresses may be low or high and all those things can happen. So, for that purpose the total rolling mill, the total line length will be very large. So, one thing is how to reduce this. This is one thing which people look at it. What are the technology which can be developed to reduce the total length of a rolling mill? So, there are now various methods which comes. So, the continuous rolling uses a series of rolling mill and each set is called as a strand. Here, as I said, there is a small spelling mistake in that. Here it should be strand. The strip will be moving at different velocities at each stage in the mill. So, what is the velocity here is different than the velocity here. This part it will be higher, and here it will be still higher, here it will be still higher, and it will be still higher. This is the velocity will change like that in this case. The speed of each set of rolls is synchronized. So, that is what, but that very accurately it may be difficult. That is why I said sometimes there may be pits may be there, so that it will go into depth and then come into that. So, but in normal case it is synchronized, so that the input speed of each strand is equal to the output of the preceding strand. The uncoiler and wind up reel facilitates feeding the stock into the rolls and coiling up the final product, in addition to providing back tension and front tension of the strip. So, if you pull it from here, you call it as a front tension. If here it is less than the velocity of the speed, then you call it as a back tension is given. So, front in one station itself, if you look, there may be back tension, there may be front tension. Depending upon that, you can move, you can reduce or increase your power requirement. But when you are adjusting for power requirement, some other drawbacks also come. So, it has to be finely optimized. Another case, because to reduce this the total length of the rolling mill is just using a planetary mill. That is also has come into the force. So, in this it consists of a pair of heavy backing rolls. So, there is a backing roll here, there is a backing roll here, and this is in contact with say your live rolls actually. The large number of planetary rolls are there, these are the small. So, the billet will be entering into this region, and then what happens is that each planetary roll gives an almost constant reduction to the slab as it sweeps out a circular path. You will find that it is sweeping out a circular path. So, here when it enters, it gives a constant reduction for between each rolls, but when it comes to here it is very less. So, it is not in line also. So, that way you can find that there is the roll gap continuously keeps on adjusting. So, this entire thing will be rotating like this, and if you really visualize, you will find that this minimum distance is not along the central line. So, that is also there. So, it can be adjusted to whatever way you want. So, as each pair of planetary rolls ceases to have contact with the workpiece, another pair of roll makes contact and repeat the reduction. So, when it is coming out from here, you will find the next set of thing will be coming in contact, and as it is moving, the height keeps on continuously decreasing. That is the biggest advantage for this. When this is moving downwards, the overall reduction is the summation of a series of small reductions by each pair of rolls. Therefore, the planetary mill hot mill reduces a slab directly to a strip in one pass through the mill. So, this way you can save large number of rolling strands. This is one advantage, but it cannot be used for very large reduction, that is another case. So, with an intermediate or small reduction, this is a very useful method, but there is a problem, because you may find that the surface which comes out, the surface of the material which comes out, there may not be, it may not be smooth, okay, because there may be roll marking and other things. Okay. For that, you may have to use planishing rolls, because once it comes out of that, it will be passed through a planishing roll, where it is made plain throughout. A simple final finishing rolling will have to be passed, but a large number of rolling strands can be eliminated and at one place. So, you can save a lot of space in this. So, that will improve that planishing rolls, it will improve the surface finish of the rolls. Now, as I mentioned, let us look at what are the advantages with the hot rolling process compared to the cold rolling process. The first hot working operation is done using a roughing mill. In the hot rolling process, from you call it as blooming or slabbing or cogging. So, where the size of the billet or ingot is very large, and then you are just first breakdown passing through the roll. So, that either you call it as bloom. When you are getting a bloom, you get blooming. If you are getting to slab, you call it as slabbing, or otherwise with where the size is very large, you call it as cogging also. So, that is called as that is done by a roughing tool, where the surface roughness will be very high, okay, not very smooth. Surface roughness will be very high, so that extensive deformation can be taken place. Generally, these are done, the first hot working operation, they are done by 2-high reversing mill, or even simple pullover also they will be doing it, depending upon the size of that. And in this case, the mill, the diameter of the roll is very important. Normally, you will find that the diameter of the rolls are between say 24 to 54 inch diameter rolls, and these two reversing mill, they will be characterized by the diameter of that. Okay. So, that is what it is. These mills are designated based on the roll diameter. But before that, see, you are keeping this billet or ingot in a furnace and taking it. For hot working operation, you have to keep it in a furnace and then you have to take it out. So, when you are keeping it in a furnace, you have to soak it there for sufficient time, so that homogeneity in the temperature across the section is obtained. So, for larger size, you have to keep it for a large time. Okay. As a thumb rule, it is called as the time required is half an hour plus half an hour per inch thickness. So, if the thickness is very large, then you have to keep it for extremely large time, because heat has to conduct, and at the center and the surface the temperature should be more or less same. So, for that temperature homogeneity, thermal homogeneity to obtain, you may have to keep it for longer time at that high temperature in the furnace. So, when you are keeping at the high temperature in the furnace, what happens is that most of the metallic materials will start getting oxidized at the surface. So, there will be an oxide layer. If it is steel, this steel, there will be scale formation. It gets oxidized and it may get separated out. So, there will be scale formation will be there. Whereas, if it is aluminum, scale formation may not be there. Aluminum will get oxidized, but a very thin layer only. It will not increase further. If it is magnesium, the PV ratio is very high, so it will become porous, and then this will just diffuse inside, and finally you will lose the material. So, titanium also, the oxygen will penetrate through the grain boundary regions, and so depending upon the material. If it is steel, there will be oxide scales. So, you have to remove the scales. So, for that you give a very small amount of deformation, a very small, initial case is very small, so that during that process the scales are get removed. You call it as descaling. Okay. And after that only, for this only small reduction is given. Once the scales are removed, then it is passed to the next stage, where large amount of deformation takes place. Okay. And so, the breakdown of the cast ingots or blooms or slabs to subsequent reductions is done subsequently, but after each one, say, as I said, it may be somewhere around 150, more than 150 diameter, and in the next step it may be 50 or something. When it comes like that, you will find most of the case it is done kept as a square itself, cross sectional area. So, once one reduction is given, the width, the thickness is lower compared to the width. So, what you do, the next step, this will be rotated by 90 degree and then past it. So, you will have on the width reduction, first is the thickness reduces, but the width remains the same. The next step, because it is rotated 90 degree, the height gets reduced, and then finally you get the same size. So, a square section you can get it. So, the ingots are turned 90 degree between subsequent passes to get the a square cross section. But for high production rates, generally universal mill will be used, okay, to take care of these edges, because when you are reducing the height, there may be a barreling which takes place, especially at hot working condition. Side where it is not in contact, then there the deformation may be lower. So, to avoid that, so that this rotation by 90 degree can be avoided to taking care of the edges. For that, what they do is that in the universal mill, after it passes through that, you will find it passes through another set of rolls which are vertically placed, so that a uniform width is obtained. Okay. And now, with the subsequent rolling, say the material is still hot at that hot temperature, it is coming in contact directly in contact with the atmospheric air which contains large amount of oxygen. So, again there is a tendency to get oxidized and form the scale. So, with the after 1 or 2 operation, no, you have to remove it, otherwise that scales will get embedded. So, for that is removed by high pressure water jets. So, after some 1 or 2 stages of rolling, you pass this high pressure water jets, then this scales will be removed. Okay. Then so that way at different stages the rolling operation takes place, and at the last finishing strand, once it passes the last or the finishing rolling operation, where minimum reduction will be given, but that time the concentration will be to get a very high surface finish and dimension, minimum dimensional tolerance. So, that is what they will be looking at it. So, at that time, once it comes out of that, there may be either, so it is sheared at some specific length. So, you will have the facility for that, or if it is very thin, it will be passed into the coiler where it will get coiled and other things. So, these are the cases which obtained in a continuous sheet by rolling operation. But though you are breaking down the microstructure and other things and getting a homogeneity in composition, the mechanical properties and the surface finish of hot rolled material will not be that good, because operation is done at high temperature. So, any type of work hardening is taking place, because at the higher temperature it will get softened also. So, many structural materials which we wanted to use, that is done by cold rolling. Maybe after certain stage, the final stages, no, it will be by cold rolling. So, for this is mainly to obtain very good surface finish, close dimensional tolerance and high strength. High strength by means of work hardening, because it is done at the room temperature. So, work hardening takes place and you will find that the strength increases. So, a large number of non-ferrous sheets are produced by the cold rolling process. Most of the case, non-ferrous sheets are generally done, because one thing is that their temperature is very less also, unless it is something like nickel base or titanium base. Other case, no, most of the non-ferrous material, that operation temperature is less. And in this cold rolling, because as I said, initial things are done in the hot condition, but towards the final, you wanted to have a control of your microstructure, you have to have a control of your dimensions, you have to have a control of the mechanical properties. So, considering all these things, the cold rolling generally it may have 3 or 4 strands only, or sorry, 3 to 6 strands only, not more. So, at 3 to 6 stations only. So, high speed for high mills are generally used, okay, for high reductions are generally used. The cold rolling is done at a high speed normally. And in the finishing strand, the minimum reduction occurs so as to obtain good surface finish and uniform thickness. Annealed steels are given. See, sometimes when you get annealed material, when you are given, no, you will find that, okay, especially steels having some amount of interstitial impurities like carbon and nitrogen and some other elements, you will find in steels, there is a yield point phenomena which is taking place. That means when you are just doing a tensile test, you will find that it reaches a maximum value and then suddenly there is a drop in the stress, it remains there constant for some time and further with the work hardening it takes place. This is called as the yield point phenomena. So, when the yield point phenomena is taking place, your material may during deformation may not be good because structure lines and other things comes. So, that may result in material which is defective, okay, because subsequently some other phenomena will take place. So, in that case, to avoid this yield point phenomena, annealed steels are given a skin pass only at the surface, or you call it as temper rolling to eliminate the yield point phenomena. In that case, some amount of deformation takes place, and so once that yield drop has taken place, then it will not go to the upper yield point, it will remain at the lower yield point, and then once the yield point elongation is complete, then you will find that the work hardening is taking place. So, that way yield point phenomena can be eliminated by giving this temper rolling or a skin pass rolling also. These are some of the photographs which has been taken from the internet. So, here this is for the sheet metal, which you can see that the sheet metal is being rolled and then it is passing into that, here it will be passing into the pit only, okay. And then this is the rolled strip which has been coiled into the coiler form, and then you are tying it properly. So, if you look at a roll forming machine, you see what is the length, it is a very huge length and other thing, it is taking very high amount of space also. This is the hot rolling condition in the coiler form. This is the temperature is very high, that is why the color is there. But if you look at the length, this is a person standing here, compared to his size, you can look at what is the length which is coming. So, it is very large amount of length is there. And you can get a special type of cold rolling in which flat slab is progressively bent into complex shape by passing it through a series of driven rolls are also there. You can get different shapes also. See, like this type shapes. Now you will find that rooftops, tin sheets in roofs are also there with a corrugated shape. These are all obtained by this section rollings and other things. So, you can get different shapes. So, here you can see that angle sections are there, the channel sections are there, say these wish sections are there, maybe different shapes we can get it. So, no appreciable change in the thickness of the metal during this process. This is for sheet metal working, okay, roll forming you call it as. Suitable for producing molded sections such as irregular shaped channels, and then finally it will be trimmed off. Okay. So, those are the things. Okay. Thank you very much.